Yeah. So welcome back to the session on your searching techniques here. In this particular session, we will be trying to cover the remaining techniques that are considered here with respect to your searching. So, before discussing that, I just want to provide you the information that whatever the information we are actually seeing in this particular slides or the previous slides, all those are being referred using this particular textbook. This is a preferred textbook what you people do have, something called as Data Structures Using C, second edition by Rima Thereja. Okay, and the soft copy has already been uploaded, and you people can have it, and you people can continue watching those. I mean, reading that particular textbook. This is the one which will be preferring most of the time. Okay, and the second book which has been provided here is something called as Data Structures and Algorithm Analysis in C. If you people get it, you people can have this also in order to access the information. But mostly till now, whatever the information I have been providing in this particular slide are related to this particular first preference book. What is the preferred book we do have here? So in the previous session, we discussed about something called a searching technique. And the first one, what we discussed here is linear search, where we have actually discussed that the particular value, whichever the value we wanted to determine, that value we are going to search from a array that has been provided, right? We have some set of values present in a particular array, something called as A. And in this, we will be trying to find this particular value. And if that particular value is available, we are going to give the position or the location of that particular value, isn't it? Like something location is nothing but the index 0, 1, 2, 3, 4, 5. So there are 6 elements. Total n value is equal to 6 elements we are having here, and among them we are trying to search for a particular value. And since we are placing this as I told you, that linear search will be used for unordered list. This will act best when we have unordered list, means it is neither in ascending order neither in descending order we are having it. So it will be in some random order, something like 5, 7, 1, 2, 8, 6, something like this. So this is a random order what we have, and in this we will try to find the value. So let us suppose the value which we wanted to search here is 8. So how this particular linear search algorithm works, we have discussed that this particular value will be compared with each and every element present in this particular array. So until and unless either the entire array has been searched and the value is not found, till that it will be keep on searching it, or until that particular value is determined. Till that time it will keep on searching. So this value 8 will be searched with 5, then to the next, and then to 1, then it will be searching to 2, and then finally you got. So whenever an element is found in the particular I mean that particular array, so the location of that particular array will be displayed. That is nothing but the position where it is located. So within an array at position 4, this particular value is present, the value which we wanted to search. So definitely the value will be returning. So here what it is going to return here is the position, that at position 4 that particular value is available. And this is the way how exactly this linear search we have discussed, and we have seen the time and space complexity. So here we discussed, and when we discussed, we said that the best complexity, the time complexity we can give is an order of 1. Why? If the element is been found in the first place itself, so you don't have to search for the remaining values. So in the first place itself, you people have got the particular value. So within one step, you got it. So order of 1 is the best case, best time complexity what we can do have. And what about the worst time complexity? So it is nothing but order of n. Maybe that element is present in the last position, maybe somewhere here, 8. So let us suppose this is 8, I mean this is 6 and this is 8. So at this particular position it is available, means we need to search each and every location one by one. So how many steps we have to consider here? Definitely if there are 7 elements or 6 elements are present, we need to consider 6 steps then only. And even if the value is not present, let us suppose the value which we are searching is not present, then also it has to go through the number of steps to the number of locations what we do have. So definitely the worst case time complexity for this will be order of n. And if you talk about average also it will be something similar to order of n. So this is what we have actually discussed with linear search. In today's class we are going to discuss about something called as binary search. Yeah, Fibonacci search is just normal, just information we are going to provide. We are not going to implement in detail in this. Only these two are the one which we are focusing more. And here the binary search is the one which we will be looking today in this particular thing. So let's see how exactly it works. So basically this is already we had discussed earlier. What do you mean by searching is nothing but determining a particular value whichever is present in an array. Okay, and based on that we will be presenting the particular location for that particular array. If the particular value is not available within that particular array, it will simply say that the particular value is not available in the array. If it is available, then it will simply display the location of that particular value. You can see here the location of that particular value will be displayed. And there are two ways we have, as we said, linear and binary search. So binary search, so if I ask you linear search here in this particular case, linear search is actually used, as I told you, that this is for unordered list. Please do remember this. Linear search is best works when it is unordered list we are having, then we can use. But if you talk about binary search, what we are going to discuss today here, this binary search will be working on a ordered list. This binary search will be working on a ordered list. Either it should be in a ascending order or it should be in a descending order. So any one of the order we need to follow. Okay, so definitely it should be a sorted order. Upon the way you people are sorting it up, based on that you people can perform this particular bind. The logic might be changing here somewhat in between. But basically whatever the elements are present in this should be in a sorted order. Then only this best means most effectively this particular binary search will be working on. So that is what we are going to see in this particular case. So this is the normal example that ascending order. As I told you, the element should be present either in ascending or descending order. Then the binary search will be much more efficient. Now, if you talk about binary search in this particular case, this is one of the searching technique, as we know that, but it works only on a sorted list. So definitely the whatever the sorted list we are having on that only it is going to work. Now, the best example for this, what we can take, what is the strategy it is going to perform in this particular scenario, we are going to see here. So in this case, what we can say is that it is, let's take an example of a telephone directory. You people are having a telephone directory at your home. Now you wanted to search for a particular number. So what he's saying is normally, we will be following index. Forget about that. In this, what he's saying is, first of all, we will try to open the directory somewhere in the middle. Means whenever you're opening a book, you will open at the middle of that particular book. Okay, and from that particular book you will be trying to find out, so whatever the middle page that has been located there, you will be comparing the name present in that particular middle page with the name what you are searching for. Now in case if that particular page something like this is an array. Okay, so with it, let us suppose this is a book. So you will be first opening the middle page here. Here you will be trying to find the name which you're looking for, and whatever the name is present in this particular page you will determine it. Anyhow, you know that telephone directory will be in a sequential order, means alphabetical order. So based on that is what we call it a sorted order. So within this particular sorted order, what you are going to do is you will just find out which name is present in this particular page. Now based on that you will try to determine, suppose in this place, for example, you're trying to search for a name that starts with letter B, and in the middle of the page you people are having something called as letter P. And now based upon this particular name or the alphabet whatever you have got there, you will be deciding whether shall we look into the first half of a particular book, or shall we look into the second half of a particular book. Since I want to search a name which is B, you know that B comes before P. So it means I need to simply ignore these particular pages and I should be focusing on these particular pages. This particular means from A to P, in between I am going to search it. Okay, so now your book size has been reduced from A to P. And here again what you people are going to do is you will be again finding it out the middle page. Again you will go for the middle page, and from that particular middle page, let us suppose this time you people got something called as F. Okay, A, F, and P. So this is what the middle page you people are having. And based upon this alphabet number or alphabet, whatever you're getting, you will decide whether we need to search this particular half or this one. So what is the name we wanted to search here is nothing but the one which starts with the letter B. So B means it is B alphabet comes before F. So we will be simply ignoring this particular area. And then we will be focusing on this particular area. Now from A to F, you will be searching it up. And then finally what happens, again a middle page you people are going to do, and you will keep searching in this way until and unless you people are getting a page which is starting with letter B. So this is what the actual strategy that has been followed in this particular binary search. Means we are going to find out a middle element first, and then we'll be working on that. For example, sorry. So I'm not good in drawing in this. I don't have a pointer. I'm using a mouse. So please don't mind for this. Here, suppose this is an array like this. We are having some values are there. This is the index I'm representing. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means how many elements are present here is nothing but 10. Since we are representing from 0 to 9, right? So there are total 10 elements are present. Now, first what we are going to do is how the binary search takes place. It will first take, now this is what I call it as a beginning. 0 is what I'm calling it as beginning, and the value which is present in 9 here, I'm calling it as end. So this position I'm calling it as end, and this position I'm calling it as beginning. So first, as I told you, the strategy what we follow is we'll try to find the middle element for this particular value, whatever we are having it. So what we are going to do is simply we are going to find the midterm. So mid is equal to beginning plus end by 2. So that you're going to get 0 plus 9 by 2. Okay, so 0 plus 9 by 2 means how much you are going to get something like 2.4.5. Since we people are storing this is an array of type what we have taken integer here. So here the middle term will be something called as 4. So this will be your middle term. So this is the way how you people are going to find the middle element in this particular scenario. Now, from this particular middle term, you people will be trying to determine which element we want to find. Since these elements, the elements what we are going to store here in a sorted order. Let us suppose 24, 25, 30, 42, 47, 50, some numbers, but it should be in a sorted order. 56, 60, 62. So here the value which I wanted to find here is something called as let us suppose 25. I wanted to find a value which is located at 125. Okay, so how this particular binary search works is mint equal to beginning plus end by 2, that is equal to 0 plus 9 by 2. So you are going to get the mid value as 4. So here the mid value what you people have received is 4. Now this is a middle term, this one, that is position 4. Now what you people are going to do is you're going to compare it. What is the next step we need to follow? We need to compare. What we need to compare? The value which we are searching with the value which is present at this particular location. So how we are going to compare is nothing but a of, so this is an array of type A, right? I'm given the variable name A. So A of mid is equal to, I'm going to check the condition. This is something like condition. If A of mid is equal to value. So what is the mid value we got here? 4. A of 4. So A of 4 is equal to value. What is the value I want to search here is 25. So what is the value we have exactly in this particular location? 47. So 47 equal to 25. So this way we are going to search it. Okay. If it is not, so this value is not, okay, 47 is not equal to 25. Next, we have to again check another condition whether this value A of mid. And remember, if A of mid is equal to value, you get it up. Then finally, you can say that you can directly display the position if you find that element at that particular location. If you did not find it, then we have to find whether the value present in this location is greater than the value what we are determining. So here what we have, 47 is greater than 25, isn't it? 47 is greater than 25. So what we have to search for? We need to search for the left half of it. This half portion we need to search. Why? Because the value which we want to search, that is 25, is less than 47. So I don't have to go for the right hand part of this. I need to search only for the left hand. Then in that case, what is the array I should get here? something called as 20, 25, 30, and then finally 42. Now this is the array which I need to search. Now if you consider this one, what is the beginning value? We have big. Then what about the end here? We don't have end. We need to fix the end because right now the end is at location 9. But this 9, now I have to convert it. This end has to be changed now to this particular location. What is this location? 0, 1, 2, 3. So the end value, this should become the end. How we can make it is very simple. Simply have to write end equal to mid minus 1. Mid minus 1 because these elements now what is the position we have here? 4 minus 1 is 3. So this 3 I wanted to make it as end. So simply how we can do end is equal to mid minus 1 because the mid value what we got is 4. So 4 minus 1 you people are going to get as 3. So now here in this case I have set this as end. Again, the same process we are repeating here. This time 0 plus 3 by 2. Again, I need to find the middle term. So this is something 1.5. Now this 1 will become the middle element in this particular case. Okay, 1.5 now. So since we have represented this as an integer data type, so this 5 will be eliminated. Only 1 will be taken here in this case. So 1 is this. Okay, and now again we will be checking the condition whether a of mid is equal to value. Now, what is the value of mid here? In this case, what we got? 1. So it will check whether a of 1 is equal to 25. So what is the value we have in a of 1 here? 25. So 25 is equal to 25, right? So finally, you can display at that at position equal to 1, the element which you're searching is available. Finally, your search is completed and you can just come out of that particular thing. So this is the way how your binary search actually works. Only thing you have to do is whichever the array you are taking here, first try to find out the middle element. And from that middle element, try to determine whether the element which you're searching is less than the value present at that location or is it greater. In case it is greater, you have to change the beginning. For example, you want to search an element. Okay, let me erase it. I'll explain it again here. For I am going for higher term now. This time 20, 25, 30, 35, 40, 45, something like this, 50. Now in this case, I wanted to go for a higher term. First, I need to find so 0, 1, 2, 3, 4, 5, 6. I want to search a value here. Let us suppose 45. Same thing. So this time again, you will be finding a mid here. So this is your beginning, right? This is your beginning. This is your end. So beginning plus end by 2. So that is 0 plus 6 by 2. So that you are going to get it as 3. So what is the value present in that particular a of 3 here is 35. And what is the value you wanted to search here is 45. So E is 35 equal to 45? No, the condition fails. Now we have to find whether the value present here is greater than 45. So is 35 greater than 45? Yes, the value what we are searching for here is greater than 45. So what we have to do, we need to search the left, okay, the right portion. This portion I can eliminate from this particular mid. This portion I can eliminate. This is the one which I wanted to search it. And when I wanted to search this, definitely the end position will not change. What this time will be changing, the beginning has to change. So what we can write, beginning equal to, where is the middle element we got here? So mid plus 1. Mid plus 1 we are going to get 3 plus 1, that is equal to 4. So this will be coming. So now we are going to search the element something called as 40, 45, 50. So here this will become your beginning and this will be as usual ending. So here this is 6, 5, 4, the index. Okay, so now again you people are going to do something called mid equal to 4 plus index 4 plus 6 by 2. 4 plus 6 by 2. So how much you are going to get? 2 5s. So 10 by 2 now. So 5. What is the middle element you got here? 5, 45. Now again you'll check the condition whether A of mid is equal to the value which you wanted to find. So mid value, how much you got here? 5. This 5. You're storing it. So A of 5, how much you have? 45. So 45 is equal to 45. Your condition satisfied. So simply you will display that at position 5. You are having the value which you people are trying to find it out. So This is the way how it is going to get it. So remember, whenever the value which you're searching is greater than the middle element, you have to change the beginning. And if the value whichever you're searching is less than the middle element, you have to change the value of end. This is what you people have to keep in mind. Remaining all cases will be very easy. Now the same thing I'm going to show it in a graphical representation using an algorithm. So here, this is the normal explanation that is given with respect to that. If the desired page, so whatever the page you people are seeing here in this particular scenario, this is related to the dictionary. What is saying middle element, fast and all. So here in this case, I am going to take this particular example. You people can see it. So here I have taken something like for 15 elements I have taken here. So 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 15. So there are total 15 elements we have. Then the value what I'm going to search here is something called as 33. I mean this value I'm trying to search. This is the value which I'm trying to search, whether it is present in this particular array or not. So array is represented using a variable A. Now first, let me show you how I'm going to store it in an array here. This is a representation. So you know that array usually begins with index 0. So I have written 0. So 0 to 14. Now I think you people can understand now this will be your beginning. So the beginning. So initially you will keep beginning is equal to 0. And what is the value? You have to initialize this. The end value you have to represent with 14. N minus 1. Total how many elements we do have here? 15. So definitely end value will be n minus 1. That is 15 minus 1 is 14. And beginning is 0. Since we are starting from 0. And based on this, this will become your end. Now I think it is easy for you people to determine the middle value here. So mid is equal to beginning. What is the value we have for the beginning here is 0. So 0 plus what is the end value we have here? 14. 0 plus 14 by 2, that is 7. Now this 7 is your middle element. Okay, this middle term, this is your middle term. Now we have to check the value present at this position with the value which we are searching, that is 33. Is 33 is equal to 53? No, the condition fails. Then we have to go for the else part. In the else part, again we'll check whether this value is less than 53 or not. Whether the searching value, whatever the value we are searching or whatever the value that is present in this location is less than 33 or not. No, 53 is not less than 33. It is greater than. Then what we have to do? We need to search in the left portion. Means from 0 to 6. I have to search. From 7 to 14, I need not have to search. So simply I will eliminate this particular portion. How can I eliminate? Simply I have to modify this end. How can I modify? End equal to mid minus 1. Because already we got the middle element 7. But in this, we don't have the value what we want. So we have to previous one we have to search. So 7 minus 1 is 6. So this will become your end. Now this time I have to search from 0 to 6. Again for this I am going to find the middle element. So 0 plus 6 by 2. So that you people are going to get it as 3. Now this will be acting. In the second iteration, this will be acting as your middle element, that is 25. Now again, you are going to search whether the value 25 is equal to 33 or not. Well, you will come to know that it is not. Then we have to search whether the value present in this particular 25, okay, in this location is greater than 33 or not. It is less than 33. Whatever the value we are searching is less than 33. What does that mean? I have to ignore this because these are in sorted order. So definitely the previous value will be less than 25 and 25 is less than 33. So I can simply eliminate this. Now what are the values we are left here is only three values are left right now. What are the three values we have? 33, 43 and 51. Now for this again I had to find the middle element, that is 4 plus 6. And remember, since I have deleted this, now this time beginning will be located at this particular position 4. So beginning end will be same. So 4 plus 6 by 2, how much we are going to get? 4 plus 6 by 2. So how much you're going to get is 5. So this will be acting as your middle element. And from this particular middle element, again, we will do the same process. We'll find whether 33 is equal to 43. No, the condition failed. Whether 33 is less than 43, condition true. We need to search the left. But if you observe here, this portion has gone, this portion. The only element that is left here is 33. Now, in this particular case, the only element finally we are left here is something called as 33. So in this case, this will be your beginning. This will be acting as your ending because this is the middle element. So end will be equal to mid minus 1. So 5 minus 1 is 4. So this will be your end. And same way beginning is also 4. Now we will find whether 33 is equal to 33. Yes, you people got the value. And finally, you people will be displaying the position is equal to 4. At position 4, you people are having this particular value. I hope you people are getting it. Now let's see a graphical representation and the algorithm for this particular logic. Okay, so previously I just did not mention it now. This is initially this is your beginning and this is your ending. And from here the working actually starts. Now this is your logic here. As you can see here, beginning is equal to lower bound. What do you mean by beginning is equal to lower bound here? Simply that you people are setting the value here. Okay, so beginning equal to lower bound is nothing but you people are setting the initial value 0. That 0 you are initializing to beginning. Same way end also you have to write upper bound now. What is the upper bound here in this case? So this is your lower bound. This is your lower bound 0 and this is your upper bound, and that is what we are actually initializing in that particular location. See here, the lower bound will be here 0 and the upper bound here will be 1. And initially we don't have any position now. So I am representing that with -1. That indicates that till now no position has been selected. Okay, fine. So we will be entering into the loop and here we have using while loop while beginning is less than equal to end. So this is what we need to determine here. Why we are checking this condition whether 0 is less than equal to 14 is, let us suppose you people have given only single element in an array 5. There are 10 locations you have given. Among this 10 location, only one value you have given something called as 5. Then how the system will determine? How the system is going to do middle? So that's why we are checking here whether it is less than or equal to. If it is less than, then sorting cannot be done because there are no elements present. And if it is equal to 0, then also we cannot do because there are no elements present in that, isn't it? So that is what he's saying in this particular scenario. So while beginning is less than equal to 10, perform this. What? We will find the middle element. So middle element is beginning plus n by 2. Okay, let me show you with the animation so that it becomes easy. Now this is a value here. So this is your lower bound. Okay. So this is your lower bound here and this is your upper bound here in this case. So what will happen? So beginning equal to lower bound now. So this will become beginning here. End equal to upper bound. So end value becomes 14. Now is 0 less than equal to 14? Condition satisfied because 0 is less than 14. Now what we have to do? We have to find the middle element. So middle element we can find it 0 plus 14 by 2. That is how much we are going to get. Beginning plus ending by 2. So 0 plus 14 by 2, 17. Now that means this particular location is your middle element. So yeah, you can see here. So this is your middle element, what you got it. Now what we need to do after that, we need to check whether A of middle is equal to value, means A of, what is the middle element we got here, position 7. Is A of 7 is equal to the value which we are determining. What is the value we are determining here? 33. So what is the value we have in A of 7? 53. Is 53 equal to 33? No. You people know very well that 53 can never be equal to 33. This condition fails. Then what we have to do? We have to simply skip and we have to come for the else part. Now in the else part, we will try to find out whether the value present in that location is greater than the value we found. So is 53 is greater than the value we are searching, 33. Yes, the value what we are searching is actually less than 53 and the value which is present here 53 is greater than 33. So what we need to do, set end equal to mid minus 1. As I told you that I have to search only for this particular location and I have to ignore this. How can I ignore it? I got the middle term. Now this end position need to be changed. So end equal to mid minus 1. So what is the value of mid we have here? 7. 7 minus 1, what is the value you're going to get? 6. Now this is the one which will be acting as end. And this we are simply going to ignore it. So let me show you how it is going to come now. Yeah, you people can see here. So this is the portion. Now this portion, as I told you, this portion is the one which I am going to search now. This all things I am going to ignore it. So here 0. So definitely this will become your beginning. So the beginning is not changing. The beginning is same. Here the beginning will be same. This is your beginning. Only ending has to change, but right now the ending is pointing to the value 14. Now this has to come here to 6. How it will come? So end equal to, what is the middle value? We have 7. So mid minus 1. So that is 6. Now this will become your end. So let me show it. So you can see mid and end, you people have got it based upon this. See, this is the logic we have used. Mid minus 1. Okay, and then what we need to do here, we need to again search a middle element for this. So again you need to find a middle element. So beginning plus ending by 2, 0 plus 6 by 2, 3 is your middle element. So you can see here clearly that you people are getting this particular 3 as a middle value. And again I am going to search. This process will be repeating again, whether if a of mid is equal to value. So a of, what is the mid value I got this time? 3. Whether a of 3 is equal to 33. What is the value present in a of 3 here? 25. Is 25 equal to 3? 33? No, the condition fails. Again it will come back to this particular location here, and then again it will check here whether a of mid is greater than the value we are searching. What is a of mid we have here? A of 3 is greater than, the value is 33. What is a of 3 we have? 25. Is 25 greater than 33? No, this time the condition failed. 33 is greater than 25, not 25. So what happens here? This condition also failed this time. Then where we have to go finally to the else part. So here in this case, what we have to do, since 25 is less than 33, so we have to search this particular portion. This particular portion we need to search, then we have to simply ignore this particular portion. So in that case, what we are going to do, we have to increment. So end value will not change. We have to search this portion, right? So here the end value will not change. What has to change here? The beginning should come here. So how can you get a beginning there? So beginning equal to mid plus 1. So what is the value of mid we have here? 3. 3 plus 1, you people are going to get it as 4. Now this will become your beginning. And from here you will be again start working on. So you can see here. So you got this 4, 6. So 4 will become your beginning now. So again, you can see here the 4 becomes beginning, 6 becomes ending. Again, you're going to find the middle element. So middle element, this one is 6 plus 4 by 2. That is 5. Okay, so the 5 is the only element we are having here. In this case, we have got 5 here. But you know, again, you will be for performing this particular thing, what we call searching and all. So you will first find whether 33 is equal to 43 or not. No, the condition exactly failed here. 43 is not equal to 33. Now again, you'll find whether that particular value is greater than the 33. So here same, a of 5 is greater than 33. So what is the value present here? 43 is greater than 33. Then finally, what you people are going to do? So you will be eliminating this portion, and only element left on the left hand side we are going to search. And we are left only with a single element, that is 33. Now in this case, beginning will be okay. What about end? We need to modify end. So end is equal to mid minus 1, because we are going left hand side. So 6 minus, so what is the middle element? We got 5. 5 minus 1, you people are getting as 4. Now this will be acting as your beginning, and this will be acting as your end. And then again you will be searching whether a of mid is equal to value. Now this time a of 4 is equal to 33. So a of 4 consists of 33. So 33 is equal to 33. Yeah, this time you got the value. So what are you going to do? This condition satisfied. So set position equal to middle. So position equal to, what is the middle value we have here? 4. Simply you people are going to print the statement POS, that is So this is the way how exactly this particular algorithm works. Very easy. So you can see beginning and ending is same. And then finally you will be performing that, you will be getting the value, the position is 4. So at location 4 you people have got that particular information what you exactly want. Now here coming to the complexity in this particular scenario, the complexity is basically given as order of log n. How it has given is, see what we are exactly doing here, whatever the array we are having here, we are actually dividing that into half and then we are searching it, isn't it? In the beginning we have total 15 elements. We found the middle term and eliminated one portion of it and we have started searching this particular portion. And in the next iteration, what we did, iteration is nothing but looping. Here while condition is there now, so there is a loop running. So here in this iteration, what we did, we again tried to find the middle element, that is 3. And based on that, we eliminated this and we have again. So every time the iteration is taking place, you people are reducing that array into half. So for based on that, they have got a function like 2 to the power fn is less than n. Okay, and applying mathematical expressions like logarithmic expressions to this, you people might be having in basic engineering, you will be getting something, the function f of n will be you will be getting it as log n to the base 2 when you solve it up. F of n is equal to log n to the base 2. Well, that is somewhat complicated if I explain this. So for timing, if you remember this, that is most enough for this particular scenario. So you will be getting f of n. So when you solve this problem, 2 to the power fn less than n, you will be applying logarithms on both sides and all. You will be getting f of n in f of n. The function is equal to log n to the base 2. What is n is nothing but the number of elements. So here number of elements is 15. So log 15 to the base 2. So what is the value people are going to get log 15? That is the value. So you people have scientific calculator. So based on that, you people can determine. So log 15, what is the value you get? That is the time it is going to take in order to execute this particular program. So this is the way how you people can identify. And coming to the space complexity, why it is order of n is, every time we are actually require one space for storing. We are taking a position here. Additionally, how much space we are taking here? Only one variable we are taking, that is POS. For that order of one we are taking. Since we are using only one auxiliary variable here, position. So for that purpose, we are actually performing. So only one space is required additionally rather than 14 spaces. Means a total 15 elements are there, 15 spaces are required. Apart from that, we are taking an additional variable called as 17. So that for that purpose, he is showing it the space complexity as order of 1. This is what how exactly we can determine. Okay, I hope you people have understood this. This is very easy. Only thing you people have to do is finding a middle term, and from that middle term trying to find the next, whether we have to go to the right half or whether we have to go to the left half, depending upon the value what we are searching. If the value is less than the middle element whatever we have, we'll go to the left half. And whenever we are going to the left half, remember the end has to change, end equal to mid minus 1. But if you're going to the right half of your middle element, then you have to increment the beginning. Okay, so the beginning has to be, so if you're searching here, then beginning should be coming here. So that will be mid plus 1, that is 8. But in case you're searching on your left half, this one, then beginning will be at this position, but ending has to change. So since it is coming to the left hand side, it should be mid minus 1, that is 6. And from this will become your ending. And from here, you people have to start working on and you have to perform the operation. So this is all related to your binary search, what we have. Okay, so with this, we have actually completed your searching algorithms, that is linear search and binary search. In the next section, we'll be discussing about the sorting techniques here, the various sorting techniques, what we do have one by one. Okay, thank you. Thank you for watching.